Hi everyone, I am Sai Kiran Gaddam. Now I am going to present a paper called Types of Software Evolution and Software Maintenance. And this paper was proposed by Chepin, Hale, Khalid Khan, Ramil and Tan. Author and journal. These are the some of the other papers proposed by these authors. Ned Chepin, A Measure of Software Complexity. Hale, Modeling Software Evolution, Defects a Time Series Approach. Khalid Khan, Wireless Networks. Ramil, Metrics and Laws of Software Evolution, The 90s View. Can, Challenging of Adopting Multiple Process Improvement Frameworks. And, and for this paper, the citation is 562. What type of software evolution or software maintenance was this? According to the Chapin's 2001 view, there are total of 12 types of software evolutions. Motivation. This paper clearly explains the redefinition of the types of software evolution and software maintenance. In this paper, the author is redefining both software evolution and software maintenance. The other motivation for proposing this paper is a finer grained objective classification of the type of activities involved in software evolution and software maintenance. Proposed classifications. In proposed classifications, we have a total of 6. First one is 3 criteria, and next one is type clusters, and the third one is support interface cluster, and the fourth one is documentation cluster, and the fifth one is software properties cluster, and the sixth one is business rules cluster. Coming to first one, 3 criteria. In this classification, first we will check the software and code experience functionality. Type clusters. Clusters itself can be classified into two types: hard clustering and soft clustering. In hard clustering, one data point can belong to one cluster only, but in soft clustering, the output provided is a probability. Support interface cluster. Support interface cluster consisting of three types of decisions, which because of their increasing impact consider in that order. Evaluate is the default type for this cluster. Documentation cluster. In documentation cluster we have two types of decisions, B1 and B2. Activities in this cluster usually build upon activities in the software interface cluster. Software properties cluster. For software properties cluster we have four types of decisions, C1, C2, C3 and C4. In this cluster, note that the code changes do change the system or the software properties. Business rules cluster. Business rules cluster we have three types of decisions, which because in their impact are considered in that order upon an extensive supportive use of activities from the other cluster. This is the decision tree for all types of clusters. We have to read the decision tree from left to right or from top to bottom. The A criterion decision is about the condition software before and after the activity. If you read the object evidence as no, then we go to the support interface cluster consisting of type decisions A1, A2 and A3. Evaluate is the default type for this cluster. A1, it will activate the use of software stakeholder training. This training type includes such activities as conducting classes for customer personnel. A2, this consultative type is very common because it involves such activities as fielding questions at the help desk for the customer personnel. A3, it will increase because of their increasing impact or considered in that order. If you read the object evidence as S, then we go to the B criterion decision about the condition of the code. If you read the object evidence as no for the B decision, then we go to the documentation cluster consisting of two types of documentation, B1 and B2. B1, it will be the non-code documentation conform more closely to the stakeholder needs. B2, This adaptive type involves updating the content and coverage and replacing the non-code documentation with current accurate documentation. If you read the object evidence as yes, then we go to the C criterion decision that asks about the changes in the system functionality by the customer. If you read the object evidence as no for C decision, then we go to the software properties cluster consisting of four types of decisions C1, C2, C3 and C4. C1. This groomative type involves source code grooming activities such as doing replacing components or algorithms. C2. This preventive type involves making changes that do not alter either the existing customer or experience functionality. C4. This adaptive type involves such process as the system work on a different platform with different kind of database. If you read the evidence as S for the C decision, then we go to the business rules cluster considering of three types of decisions D1, D2 and D3. The activities here are among the most frequent and the most significant in software evaluation and maintenance. This reductive type of particular significance for software evaluation involves limiting data flows may be eliminated or reduced in D1. D2. This corrective type involves refining and making more specific the implementation to the internal logic or algorithms. D3. The enhanced type of particular by inserting new components, algorithms or subsystems, new data flows may be added and existing data flows may be redirected. Application. We looked at the two types and note the performance is higher than evaluator maintenance to do their work differently in different organizations. Cluster. In cluster we have four types: business rules, software properties, documentation and support. For business rules the specific type is enhansive, corrective and reductive. For these three both software evaluation and software maintenance will work, where E indicates the software evaluation and M indicates that software maintenance. For software properties cluster we have total of four. First one is adaptive and performative. For adaptive and performance both software evaluation and maintenance will work. For preventive and groomative only software maintenance will work. For documentation cluster we have total of two, updative and reformative. For these two only software maintenance will work. Support interface. In support interface we have of three, evaluative, consultative, training. In these three only software maintenance will work. Discussion. Software evaluation occurs has no widely accepted definitions. Others prefer a narrow view that the software evaluation occurs when either enhanced or reductive maintenance is carried out. For example, while producing the initial version of a system, correcting an oversight logic bug detected during unit testing qualifies as correctively software maintenance. For example, does also qualify as software evaluation as well as software maintenance. We locate the two types and note the performance is higher than evaluator. This means that we could have expected in these examples to see the evidence of the training, consultative, reformative, groomative, and this helps us ask potentially fruitful questions. Are the missing types because of oversight and observation the objective evidence or because they indicate activities not done? Conclusion. In this paper, so the author is going to redefine both software evaluation and software maintenance, recognizing type based on objective evidence instead of based on intentions, pointing to the software, the code, and the customer experience functionality as key determinants of the types, identifying observable activity, extending type applicability to both software evaluation and software maintenance, and the approaching the classification of activities in an illuminating way for practitioners and their managers as well as for researchers, pointing to the software, the code, and the customer experience functionality as key determinants of this type, providing a somewhat finer granularity for the types with four named general types as clusters, instead of the current total of three types: corrective, adaptive, and preparative, providing a detailed granularity for the types with 12 named types. Acknowledgements. This paper is a revision, extension, elaboration, and expansion of paper by the Chapin published in IEEE Society Press. Thank you.